graph is encountered regularly from weather forecasts and TV report cards, all representing collected information in numerical form. Data, essentially information, is often graphically displayed, and one common visual tool for this purpose is the bar graph, known for its simplicity and effectiveness in presenting and comparing data. Graphs are like pictures we see every day, like on the weather forecast or report cards. They help us understand information with simple pictures, and one of the easiest one is the bar graph. It's like a visual tool that makes it simple to compare and understand different amounts of things.
The use of graphical representations, such as bar graphs, in data analysis has a rich history, with notable contributions from several individuals, starting with Nicole Oresme in 14th century. He is a French scholar, made significant contributions to various fields such as mathematics, physics, and astronomy. In his work, The Latitude of Form, Oresme employed a rudimentary form of a bar chart to visualize the velocity of a constant accelerating object against time. This pioneering use of graphical representations laid the groundwork for future developments in data visualization. Next, we have Joseph Priestley, an English polymath. He is known for his contributions to chemistry, theology, and education. In 1765, Priestley designed a chart of biography as a visual aid for his lectures on history and general policy. His chart utilized horizontal bars to represent the lifespan of individuals, allowing for easy comparison between different historical figures. Priestley's innovative approach to data visualization marked another milestone in the evolution of bar graphs. Lastly, we have William Playfair, a Scottish engineer and economist. He is credited with the modern invention of the bar graph. In his seminal work, The Commercial and Political Atlas, he published it in 1786 and introduced the various graphical techniques for representing economic data. One of his notable contributions was the depiction of exports and imports of Scotland using bar charts, providing a clear visualization of complex data sets. Playfair's pioneering efforts in data visualization revolutionized the way information was presented and analyzed, cementing his legacy as one of the founding figures of modern statistics.
Now, before we go further in this topic, let us first describe what is a bar graph. So, a bar graph is a visual representation of data where rectangular bars of varying lengths or heights are used to depict the values of different categories or the groups. The length or height of each bar represents the quantity or frequency of the data it represents. The bars are typically arranged along a horizontal or vertical axis, making it easy to compare and analyze the data visually.
So today we are going to talk about the different types of bar graphs. The different types of bar graphs. First, we have vertical bar graph. It refers to the group data that are represented vertically in a graph. The data is represented along the y-axis of the graph and the height of the bars shows the value. Second, we have horizontal bar graph. It refers to the group data that are represented horizontally in a graph. The data is depicted here along with the x-axis of the graph, and the length of the bars denote the values. Third, we have the group bar graph. It is also called clustered bar graph. It is used to represent a discrete value for more than one object that shares the same category. A group bar graph is the type of bar graph in which different sets of data items are compared. Fourth, we have stacked bar graph. It is also called as composite bar chart. The stacked bar chart requires specific labeling to show the different parts of the bar. In a stacked bar graph, each bar represents the whole and each segment represents the different parts of the whole. So in this slide, it shows the different illustrations of the types of bar graphs. So now there are different parts of bar graph. First, we have the data. It is the most important part of the bar graph, where it shows the information or data being shown in your graph. Second, we have the title. The title shows a short explanation of your graph. It helps the reader identify what they're about to look at. Third, we have the vertical axis. It is also called the y-axis. It has the numbers or amount of the information being measured. Fourth, we have horizontal axis, also known as x-axis. It runs horizontally and shows the numbers representing different time periods or names being compared. And lastly, we have the legend. It indicates what each bar represents. So in this slide, this shows an example of the components of a bar graph.
These are the following steps of making a bar graph. The first step is to identify the data. Choose the database that you wish to be displayed. This could be either categorized or numerical data or both. The second step is to select axis. Choose the variable that will be plotted on the x and y axis. Generally, the categories or groups are shown on the x-axis while the values or frequencies are shown on the y-axis. The third step is to select the scale. Depending on the distribution and range of your data, select the appropriate scales for the x and y axis. Make sure the scale is readable and positioned uniformly. The fourth step is to create bars. On the graph, create bars for every category or data point. Each bar's length or height corresponds to the value of the associated data point. The fifth step is to label the axis. Clearly, label the y and x axis with informative titles. If appropriate, include the units of measurement. The last step is to add the title. Give your graph a title that captures the essence of the information it shows. The title needs to be understandable and instructive.
This is the first sample for the sample problems. The bar graph on the right represents the number of patients encountered by 4 nurses in a hospital during their 12-hour shift. So Nurse A got 9 patients for their 6 a.m. to 12 noon shift and 7 patients for their 12 noon to 6 p.m. shift. Nurse B got 11 patients for their 6 a.m. to 12 noon shift and 13 patients for their 12 noon to 6 p.m. shift. For Nurse C, they got 15 patients for their 6 a.m. to 12 noon shift and 8 patients for their 12 noon to 6 p.m. shift. Lastly, for Nurse D, they got 14 patients for their 6 a.m. to 12 noon shift and 7 patients for their 12 noon to 6 p.m. shift. So the first question for this problem is, what is the total number of patients encountered by all the nurses combined? Second, which nurse encountered the fewest number of patients? Third, if each nurse is expected to encounter an equal number of patients, how many patients should each nurse have to see?
To answer question 1, we first have to identify the individual patients encountered by each nurse. So Nurse A had 9 patients and 7 patients, which equates to 16 patients. Nurse B had 11 and 13, a total of 24 patients. Nurse C had 15 and 8, a total of 23 patients. And Nurse D had 14 and 7, a total of 21 patients. So adding all these values, 16, 24, 23, 21 is equal to 84 patients. So the total number of patients encountered by all nurses combined is 84 patients. Number 2. Since Nurse A only encountered 16 patients, then he or she encountered the fewest patients among all other nurses. Number 3. To answer this question, let us divide 84 by the total number of nurses. So 84 divided by 4 is equal to 21 patients. So each nurse have to see 21
In
patients.
this problem, we're given data representing the number of patients encountered by each nurses. To find the total number of patients encountered by all the nurses combined, we add up the number of patients by each nurses, starting with Nurse A with 9 and 7 patients, which gives us a total of 16 patients. Nurse B with 11 and 13, which gives us 24 patients. Nurse C with 15 and 8, which gives us 23 patients. And Nurse D with 14 and 7, which gives us 21 patients. So adding these numbers together, we get a total of 84 patients encountered by all the nurses combined, and comparing these totals, we get that to determine which nurse encountered the fewest patients, we compute the total for each nurses. So in this case, Nurse A encountered the fewest patients with a total of 16 patients. If each nurse is expected to see an equal number of patients, we divide the total number of patients, which is 84, by the total number of nurses, which is 4, and this gives us an average of 21 patients that each nurse should have to see.
Assume a nursing home wants to compare its resident average calorie intake through 4 distinct meal options: breakfast, lunch, dinner, and snacks. They've been collecting data for a week and want to visualize it with a bar graph. The data is as follows.
In this math problem, we're given data representing the calorie intake of the residents of the nursing home for 4 meal options: the breakfast, lunch, dinner, and the snack. The data are collected over a week. For breakfast, the total calorie intake is calculated by adding up the consumed calories each day. So starting with 445 plus 535 plus 475 plus 555 plus 490 plus 515 and plus 485, and it will give us a total calories of 3,500. So to find the average calorie intake for breakfast, we divide the total number of calories intake by the number of days, which is 7. So it would be 3,500 divided by 7, and it will give us an average calorie intake of 500 for breakfast. Similarly for lunch, the total calorie intake is 610 plus 630 plus 625 plus 645 plus 650 plus 625 and plus 590, and it will give us 4,375. Dividing this total by 7, and it will give us an average of 625 calories per day for lunch. For dinner, the total calorie intake is 550 plus 595 plus 570 plus 625 plus 575 plus 560 and plus 550, and it will give us 4,025. So dividing this by 7, we find that the average calorie intake for dinner is 575 calories per day. And lastly, for snacks, the total calorie intake is 275 plus 260 plus 230 plus 275 plus 250 plus 225 and plus 295, and it will give us a total calorie of 1,750. Dividing this total by 7 gives an average of 250 calories per day for snacks.
Overall, bar graphs simply complex data into clear visuals, enabling easy comparison between categories and highlighting trends over time. This makes them a valuable tool for communications and understanding information in everyday life. Its uses do not just limit to academic context alone, but also extend to other settings as well.